segment length, and midpoints. In geometry, some of the names of figures and other terms will already be familiar from everyday life. For example, a ray, like a beam of light from a spotlight, is both a familiar word and a geometric figure with a mathematical definition. The most basic figures in geometry are undefined terms, which cannot be defined using other figures. The term point, line, and plane are undefined terms. Although they do not have formal definitions, they can be described as shown in the table. A point is a specific location. It has no dimensions and is represented by a dot. The reason it's an undefined term is not because we don't have a definition for it, but because it can't be defined by other things that already exist. So a point is a specific location, and then the ways that we name that type of figure is point P. A line is a connected straight path, and it has no thickness and continues forever in both directions. There are several ways that we can name a line. For example, we can name it line L, or we can name it based on points that lie on the line, such as AB or BA, or we can use those notations with the line symbol above the letters. A plane is a flat surface. It has no thickness and it extends forever in all directions. We can name a plane using a letter R, for example, or we can name a plane using multiple points. So plane XYZ, because all three of those points lie within that plane. In geometry, the word between is another undefined term, but its meaning is understood from its use in everyday language. You can use undefined terms as building blocks to write definitions for defined terms, as shown in the table. A line segment is a portion of a line consisting of 2 points and all points between them. The reason this is called a defined term is because it's based on the undefined term of a point and the undefined term of a line. So it's built off of pre-existing terms. And the way we name line segments is we can say the word segment, or we can use the notation above the letters. A ray is a portion of a line that starts at a point, so there's that undefined term in there, point, and continues forever in one direction. We can use the word ray, or we can use the arrow pointing off in one direction to notate that it is a ray. You can use points to sketch lines, segments, rays, and planes. Draw 2 points J and K, then draw a line through them. Remember that a line shows arrows at both ends. Draw 2 points J and K again. This time draw a line segment with endpoints J and K. A line segment does not continue on forever in both directions. Draw a point K again and draw a ray from endpoint K. Plot a point J along the ray. So it stops on K, but it continues forever in the other direction. Draw 3 points J, K, and M so they are not all on the same line. Then draw the plane that contains the 3 points. You might also put a script letter, like a cursive letter, such as B, on your plane. Give a name for each figure you drew. Then use a circle to choose whether the type of figure is an undefined term or a defined term. So we had points J, K, and M, and those are undefined terms. They are the building blocks for other terms. We have line JK, and it is also an undefined term. We have segment JK, which is a defined term. We have ray that starts at K and heads towards J, and that is a defined term. And we have plane JKM as an undefined term. In step C, would ray JK be the same ray as ray KJ? Why or why not? No. The rays would go different directions if you change the letters. In step D, when you name a plane using 3 letters, does the order of the letters matter? No. The plane can be named JKM, MKJ, or MJK, or KMJ, or JMK. Any of the orders will work. If line PQ and RS are different names for the same line, what must be true about points PQ, R, and S? All 4 of those points must lie on the line. They don't have to be the same 4 points, but all 4 of the points have to be on the line. The distance along a line is undefined until a unit distance, such as 1 inch or 1 centimeter, is chosen. You can use a ruler to find the distance between 2 points on a line. The distance is the absolute value of the difference of the numbers on the ruler that correspond to the 2 points. This distance is the length of the segment determined by the points. In the figure, the length of segment RS, written RS or SR, is the distance between points R and point S. So we see R is at 1 centimeter and S is at 4 centimeters. So they subtract those 2 numbers and find the absolute value, which gives us a distance of 3. If we start the opposite direction, 1 minus 4 is negative 3, but the absolute value still comes out to a distance of 3. Points that lie on the same plane are called coplanar. Lines that lie on the same plane but do not intersect are parallel. Points that lie on the same line are called collinear. The segment addition postulate is a statement about collinear points. A postulate is a statement that is accepted as true without proof. Just like undefined terms, postulates are building blocks of geometry. They build off of postulates to form theorems, and so on. So postulate 1, segment addition postulate. Let A, B, and C be collinear points, meaning they all lie on the same line. If B is between A and C, then segments AB plus BC will equal AC. So they're adding those 2 segments together to form a longer segment. A construction is a geometric drawing that produces an accurate representation without using numbers or measures. One type of construction uses only a compass and straight edge. You can construct a line segment whose length is equal to that of a segment using these tools, along with the segment addition postulate. In this example, use a compass and straight edge to construct a segment whose length is AB plus CD. The first step is to use a straight edge to draw a long line segment, longer than these. Label an endpoint X. See the art drawn in step 4. So they've drawn a long line and they've labeled it with an endpoint X. Then they are going to copy segment AB by opening their compass to the distance of AB. So they've shown you in that step how to open your compass. One will have the point and the other will have the pencil. So you're going to open up your compass so that it is on A and B, like so. Then you are going to come down here to X, and you are going to swing an arc with that compass, like you see here. Then to copy segment CD, you're going to open your compass to this new distance, CD. And place the compass point on Y and draw an arc. So here's our compass. We've drawn our new arc at Z. And this is where the second arc and the segment intersect. So XZ, this whole segment here, is the same distance as if we were to add AB and CD together. There isn't a compass tool in this program, so I inserted a clip of me doing this. Step 1 is to use the straight edge to draw a long segment and label an endpoint with X. Then we copy segment AB by opening the compass to the distance AB. And place the compass point on X and draw an arc. Label the point Y where the arc and the line segment intersect. I'll do that at the end. Then copy segment CD by opening the compass to the distance CD. Place the compass point on Y and draw an arc. Label that point Z where the second arc and segment intersect. Look at the line and ruler above example 1. Why does it not matter whether you find the distance from R to S or the distance from S to R? The formula uses absolute value, so the distance is always positive and the order doesn't matter. In part B, how can you check that the length of segment YZ is the same as the length of segment CD? We can use a ruler to measure both YZ and CD to see if the lengths are the same. Use a ruler to draw a segment PQ that is 2 inches long. Then use your compass and straight edge to construct a segment MN with the same length as PQ. So I started by drawing a long line, and then I opened up my compass to the same length as PQ. And copied it down to the line with M on it, swung an arc, and labeled that part where they intersect with N. The Pythagorean theorem states that a squared plus b squared equals c squared, where a and b are the lengths of the legs of a right triangle and c is the length of the hypotenuse. You can use the distance formula to apply the Pythagorean theorem to find the distance between points on the coordinate plane. Here they have the formula, but really what they're doing is finding the distance in the x-coordinates and the distance in the y-coordinates and squaring them, then combining them and taking their square root, just like a squared plus b squared, but instead of it equaling c squared, they're taking that square root to solve it all in one step. Example 2 says determine whether the given segments have the same length. Justify your answer. The difference between the x values of point A and B is 5, and the y values of A and B is 2. 5 squared is 25, 2 squared is 4, 25 plus 4 is 29, so we have that length is the square root of 29 because AB is really the hypotenuse of this triangle, which is a 2 by 5. As for CD, the difference in the x values is 2, and the difference in the y values is 5. 2 squared is 4, plus 5 squared, which is 25, gives us 29. And again, we're looking at this triangle that is a 5 by 2. And since CD is the hypotenuse, to solve for its length, we need to square root. So AB is equal to CD because they both have a length that is equal to the square root of 29. Therefore, they have the same length. The coordinates of E is -3, 2, and the coordinates of F are -2, -3. G has the coordinates -2, -4, and H has the coordinates 2, 0. Starting with the X values, we have F is -2 and E is -3. That is a difference of 1. The Y coordinates, we have -3 for F and 2 for E, which is a difference of 5. Going backwards. 1 squared is 1, 5 squared is 25. Add them together, you get 26. For G and H, we have 2 and -2 for a difference of 4. And for the Y coordinates, we have 0 and -4 for a difference of 4. 4 squared is 16, plus 16 would be 32. So EF is not the same as GH. Therefore, EF and GH, the segments, do not have the same length. Consider how the distance formula is related to the Pythagorean theorem. To use the distance formula to find the distance from U to V, you write UV equals the square root of 3 minus -3 squared plus 4 minus -1 squared. Explain how 3 minus -3 in the distance formula is related to A in the Pythagorean theorem, and how 4 minus -1 in the distance formula is related to B in the Pythagorean theorem. In the Pythagorean theorem, A and B are the lengths of the legs of a right triangle, and C is the hypotenuse. Since UV is the C, or the hypotenuse, we would square root both sides, so we would get A squared plus B squared inside those square root symbol. And then A is the leg, and B is another leg. So if we look at this triangle here, we have 1, 2, 3, 4, 5, 6, which comes from 3 minus -3. That would be the length of A. And over here, we have 1, 2, 3, 4, 5, which is 4 minus -1, the length of B. Determine whether JK and LM have the same length. Justify your answer. Well, for JK, we see that there is a horizontal leg that is 2 and a vertical leg that is 3, which is 4 plus 9 for a square root of 13. And LM has a horizontal leg that is 3 and a vertical leg that is 2 for a square root of 9 plus 4, which is also 13. So JK is the same length as LM. The midpoint of a line segment is the point that divides the segment into two segments that have the same length. A line, ray, or other figure that passes through the midpoint of a segment is called a segment bisector. It splits it into two equal parts. In the figure, the tick mark shows that PM is equal to MQ, therefore M is the midpoint of PQ, and line L bisects PQ. You can use paper folding as a method to construct a bisector of a given segment and locate the midpoint of a segment. In example 3, we will walk you through the steps. Use paper folding to construct a bisector of each segment. Here they have a segment AB on the paper. Use a compass and straight edge to copy AB onto a piece of paper, like you see here. Fold the paper so point B is on top of point A. They've shown it in a transparent paper so you can kind of see that they line up. Open the paper and label where the crease intersects the segment as point M. Point M is the midpoint of AB, and the crease is a bisector of AB. If we were to repeat this process with the segment JK, step 1 is to use a compass and straight edge to copy JK onto a piece of paper. Fold the paper so that the point K is on top of the point J. Open the paper, label the point where the crease intersects the segment as point N. Point N is the midpoint of JK, and the crease is a bisector of JK. Make a sketch of your paper folding construction or attach your folded piece of paper. You do not have to do that step. Explain how you could use paper folding to divide a line segment into 4 segments of equal length. We would start by using the folding method to construct the midpoint. Then we would use the same method to find the midpoint of the 2 new segments. The 3 points divide the segments into 4 equal lengths. Explain how to use a ruler to check your construction in part B. We would measure each of the segments to check that they have a length that is half as long as the original segment. You can use the midpoint formula to find the midpoint of a segment on the coordinate plane. Essentially what they do is they find the average of the x coordinates and the average of the y coordinates to figure out the midpoint. Show that each statement is true. If segment PQ has endpoints P at -4, 1 and Q at 2, -3, then the midpoint M of segment PQ lies in quadrant 3. Use the midpoint formula to find the midpoint of PQ. Substitute the coordinates, then simplify. We can see here they've added the 2 x coordinates and divided by 2. Then they've added the 2 y coordinates and divided by 2 to find that the coordinates of the midpoint are at -1, 1. The third quadrant has negative x values and negative y values. If RS has the endpoints R at 3, 5, and S at -3, -1, then the midpoint M of RS lies on the y-axis. Use the midpoint formula to find the midpoint of RS. R has an x-coordinate of 3, and S has an x-coordinate of -3. 3 plus -3 is 0, and 0 divided by 2 is 0. R has a y value of 5, and S has a y value of -1. And adding those together, we get 4. 4 divided by 2 is 2. So that is on the y-axis. Since the x-coordinate is 0. If AB has endpoints 6, -3, and B has -6, 3, then the midpoint is the origin. We will add the x values and divide by 2, and add the y values and divide by 2. 6 plus -6 is 0. 0 divided by 2 is 0. -3 plus 3 is 0. And 0 divided by 2 is 0. So that is true. If JK has the endpoints 7, 0, and K has -5, -4, then the midpoint lies in quadrant 4. 7 plus -5 divided by 2, that would be 2 divided by 2, which comes out to 1. And 0 plus -4 divided by 2, that would be -4 over 2, is -2. The fourth quadrant has x coordinates that are positive and y coordinates that are negative. So it has a positive and a negative, therefore it is in quadrant 4. Explain why the distance formula is not needed to find the distance between 2 points that lie on a horizontal or vertical line. If 2 points lie on a horizontal or vertical line, they share a common coordinate. So to find the distance, you just need to find the difference between the remaining coordinates. When you use the distance formula, does the order in which you subtract the x and y coordinates matter? Explain. No. Since they are squared, the answer will come out the same either way. When you use the midpoint formula, can you take either point as x1, y1 or x2, y2? Why or why not? Yes, because we are adding in the midpoint formula, and addition is commutative. What is the difference between finding the length of a segment that is drawn on a sheet of blank paper and a segment that is drawn on the coordinate plane? On paper, we use a ruler, but on the plane, we use the distance formula.